So this video is going to introduce you to natural logarithms and also solving equations with exponentials. First of all, we're going to go through a quick recap of using logarithms to solve equations. So we're going to start with a really simple one, which we haven't done for a long time, and it's just worth probably reminding you of an easier way to work out questions like this. So first of all, if you've got a power of x in your equation, we are very used now to taking logarithms of both sides, so log 3 to the x equals log 20, and bring the x down to get then that equals log 20, and then to get x we divide by log 3. And the good thing about that method is that that works for really complicated equations where you've got a power of x as well. So I do like that one because of the fact it works for all of them. Just a quick reminder as well though, that if you have got something that is quite simple like that, the other way you can do it is if you've got, for example, it's 3 to the power of something. Well, if you did log to the base 3, therefore of 20, that would actually give you the answer in one go. Now obviously that only really works where you've got simple equations like that. So for example, the next one as well, if it's 5 to the power of something that equals 16, we can just do log to the base 5 of 16, and again that would give you then what x is. So there's both ways work. Like I said, the good thing about that one is that it works for everyone, but if it is a quick question, obviously knowing that as well just speeds it up a little bit. So we did mention this back in class, but it was a long time ago. So also just another thing just to quickly recap and remind you, the graph of y equals e to the x. So these are exponential graphs, and remember we said for the value e, the exponential graph would look the same as all the others really, where it goes through 1. But the thing about y equals e to the x is that if you worked out the gradient along that curve and drew the graph of the gradient, so drew the graph of dy by dx, it would look exactly the same as this one, and we'd basically like lie on top of it because it would be the same. So that's the value that that works for, where the gradient would be the same as the actual graph itself, which is why when you differentiate y equals e to the x, you still get e to the x. Okay, because they are exactly the same thing. So sometimes then, moving on from that, so that's just like a quick recap of what we have done already, but like I said, it's been a little while. So moving on from that, if you're trying to solve equations now with exponentials, these are really similar to begin with to the ones that we were looking at up here. So again, there's a couple of different ways that you can solve them. So I'm going to do it first of all the easier way. So if we know it's e to the power of x, then we need to do log to the base e of 5 to get us what x is. And there's a special name for log to the base e, which is the natural logarithm, which is your title for today. So it's called a natural logarithm, and rather than writing log to the base e every time, we write it as ln, or it can be pronounced as ln as well. So some people pronounce it ln, some people pronounce it as ln. I pronounce it as ln just mainly because that's how I was taught it. So now I'm going to teach it that way as well. But if you would rather call it ln, then that's fine. But I just think ln gets it done and over with in one syllable rather than two. So like to me that's quicker. So I'm just going to say ln. So basically on your calculator you have got a ln button. So on mine it is here. There, so ln or ln is there, so you can just type in ln 5 and close your bracket, and so you should get then, I can't actually see what I'm doing because it's really dark. Also my calculator's a bit weird at the moment, but you would close your bracket and press equals, but my calculator's not working the best at the moment. So carrying on from that, the other way that you could solve this is rather than taking like logarithms of both sides, when you see an exponential in your equation, it's kind of like a good thing now to start thinking, right, I'm going to ln both sides. So rather than taking logarithms, you're going to ln both sides, which is like taking logarithms really. It's just that e and ln are what we call inverses of each other. And what I mean by that is that if you typed in on your calculator ln e, then you get a value of 1. So basically they are what we call inverses, and you'll do more on that in year 13. If we carry on with this now, we're going to treat this like they are logarithms, so we're going to carry on like we do with logarithms. So bring your x down, so it'll be x ln e equals ln 5. So you can see then, ln e, we just said is 1, so it would be x times 1, which is just x. So x equals ln 5, so the same as we got up there. So obviously for this one again, that's much quicker. So if it is a simple question like that, you could just do it that way. However, when you start getting onto more complicated ones, it's a good idea to learn both sides like we were taking logs of both sides in those ones. So next one again is a very simple one. So you might just think, right, e to the something equals 2. So let's just do log to the base e of 2. So ln 2. And that will get you what x is. I'm just going to quickly do it the other way just to get you used to doing that. So the other way is to learn both sides. You bring the power down, and ln e is 1, so x equals ln 2. So from there you might have to work that out if it says to round your answer, but if it wants an exact answer, you'll keep it in terms of ln. So that's it for those ones. And I'm just going to go through now some slightly more complicated ones. So, excuse me. So just one thing to mention is that you want to get the exponential on its own before you learn both sides. So for example, in these two, these would be fine to learn both sides straight away because the exponential's on its own. Whereas this one, you've got a 5 in front of it, so you'd have to get rid of that 5 first before you can learn both sides. I kind of wish I was teaching this with you at the moment just to see your reaction to the word learn. So this one, if we've got the exponential on its own, so let's learn both sides. So learn. So then bring the power down, and make sure when you bring that power down, it goes into brackets. And again, you're going to get that that equals 1. So every time, you might, to be honest now, be able to skip a kind of step here, because when you learn this side, ln e is always 1, and so you just get that 2x plus 3, or the power part left. So the next one we might just try skipping that step out, just because it does save a little bit of time, because you're always going to get ln e, and that always equals 1. So you might be able to go straight from this step to 2x plus 3 equals ln 7, and then we'd have to minus 3, so 2x would equal ln 7 minus 3, and then divide by 2. So again, if it wanted an exact value, you could leave it like that, or you could say it's a half ln 7 minus a half, 3 over 2. Obviously, if it wanted it rounded, then you'd have to work that out on your calculator. So the next one, so again, let's learn both sides. So that's just going to give you the power, because if you brought that in front, ln e is just 1 anyway, so you're going to get minus x plus 2 equals ln 10. So carrying on from that, if we add the 10 over to make it positive, so you'd get ln 10 plus x, and then you'd have to minus ln 10, so x equals 2 minus ln 10. So again, that would be your exact answer, but if it wanted it rounded, you'd have to work it out. Right, the next one, like I mentioned earlier, we haven't got the exponential on its own, so you want to divide by 5 first, so e to the 3x equals 2 divided by 5, or 2/5. Now we can learn both sides, so ln e to the 3x equals ln 2/5. So bring the power down, we know ln e would be 1, so it would be 3x equals ln 2/5, and so then you'd have to divide by 3, so ln 2/5 divided by 3. Right, the next one then you can see looks a little bit different. So with this one, you should hopefully be able to spot that this looks a little bit like what we were doing the other day when we were using quadratics to solve other equations. E to the x squared is e to the 2x. So what we can do is make a substitution by letting y equal e to the x. So that would mean that e to the 2x is y squared, because e to the x squared is e to the 2x. So it'll be y squared plus 5y, and then if we minus the 14 to make this equal 0 because it's quadratic. So that now you should be able to see is going to factorise, so y plus 7, y minus 2. So you're going to get y equals minus 7 and y equals 2. So remember, it's not y that equals minus 7 and y that equals minus 2, it is actually e to the x that equals minus 7 and e to the x equals 2. So exponentials in the equation, so we're going to have to learn both sides. So when you do learn e to the x, you're just going to get x. And if you try to work this out on a calculator, sorry, I just raised that over. If you try to work that out on a calculator, then there would be no solutions because it's like logarithms, you can't have a negative one. So if you tried that, it would just say no solutions or error. Right, this one, again, you would learn both sides. So it'd be x equals learn 2, or you may have been able to spot that straight away from that because it's just log to the base e, so learn 2. And you can, again, either work that out, or if it wants exact values, so I'm just, because my calculator's rubbish at the moment, I'm just going to leave it as an exact value. But like I say, if it wanted it rounded, then you'd have to work it out and round it.